Hi folks, Tom Affolter here again, and I'm continuing my lecture series on C#, and today we're going to be talking a little bit about strings and all the cool stuff that we can do with a string. So I'm going to start the lecture off a little bit by talking about the basics of a string, how you declare a string, and what the sizes of a string can be. And then we're going to take a look about string manipulation throughout the rest of this demonstration. And we're going to talk about some specific commands that we're going to look at. We'll review the parse, and I'm going to show you the tryparse command. It's a variation of parse that we haven't looked at yet. We'll talk a little bit more about concatenation and some ways that we concatenate strings. Then we're going to take a look at a string as an array, because we think of a string as a single object, but the fact is we can deal with a string as though it is an array, and in fact, behind the scenes it really is an array. And then we're going to talk about splitting that string up into an array based on some kind of delimiter. We can tell it between commas, pull every string out and make that into an array, or spaces. We're also going to talk about how to test an array a different way, or not an array if you will, but a string, whether or not that is a null or an empty value. It's just a quick way to do it. Again, keep in mind that some of the examples I'm going to show you, there's multiple techniques to do exactly the same thing. So we can write code right now. We've already done that to determine whether or not a string is empty or null. We can ask, is the string equal to an empty string? Or we can come back in and say, is it equal to null? There's actually a method made that makes it a little bit easier. We're going to continue on talking about how we search a string for specific information. Maybe a string has a word in it that we want to find. Then we'll look at joining strings from an array or a collection, kind of like concatenation, but not the same thing as. It allows us to take different strings and plug them in together using a different method. Then we're going to look at substring. Substring allows us to go back in and grab a portion of a string out. We can tell it start at position 4 of the string and grab it all the way to the end of the string. Or I can tell it to start in the middle of the string and give me the next 5 objects or items, if you will. Then we're going to talk about converting the case of a string. How do I convert a string into uppercase or into lowercase? We're going to remove or replace characters in a particular string. So this is like a search and replace command. Find this occurrence of this information in a string and replace it with this. We're going to talk about inserting characters inside of a string. Now, unlike the replace, which replaces an existing character, the insert allows us to go to a specific location and insert characters by spreading the string out. We'll talk about trimming a string. I mentioned that earlier. Trimming a string includes things like pulling spaces off the end of a string or off the beginning of a string. Then we're going to talk about padding a string. How we have a string that might be 10 characters wide, we have 3 pieces of information in it, we can fill the rest of the 7 characters with any character that we would like. Then we're going to close out on some real powerful stuff here, starting with formatting the data of a string. We'll look at the string.format command and all the cool stuff that it can do for us. Extremely powerful. This is kind of related to that toString method we talked about earlier, where we can put a C or a P inside of that and have it format for currency, or if we want it for percentages. And then at the end of this, we're going to look at extension types. I'm going to show you how to go back in and add in commands that don't already exist in a string command. For example, left or right. If I want to pull the left 5 characters off of a string or the right 5 characters off a string, I want to have that ability. It's not built into the string, so let's add it ourselves. We'll also add another one, the proper command. There is no way right now of going back in and converting a string where the first character is uppercase and the rest of it is lowercase. I will show you an extension method on how that can get done. When you first involve yourself with programming, you think coding is all about writing formulas and numeric algorithms. But in fact, programmers spend a large portion of their time on string manipulation, not only numeric algorithms. If for no other reason than most Windows and web form controls tend to return values as a string. You then are forced to cast that string into some kind of numeric variable if it's applicable. So information is power, whether the information is numeric or string. And as a developer of database applications, I spend an inordinate amount of time formatting and converting and cleansing data. I do the work with, or I manipulate data on the database directly using SQL, or I can work with C# on my desktop or web application before I send it to my database server. So what is best? Manipulating your data or cleansing your data at the database side, or doing it at the C# side? That's a loaded question. If I'm cleaning existing SQL data, then I'm going to first try to do it on a SQL server. or whatever database server you would have. That's the fastest method. But SQL is extremely limited in its string manipulation versus those same methods that we would have inside C#. Occasionally, you might need to convert data into the correct format before it hits your database, perhaps after a form is filled out or while reading data from a file. An example is reading a comma delimited file. Maybe I want to convert the text to upper or lower case, or maybe format that part number before it's written to my database. In that case, we're manipulating strings. I think perhaps my most lucrative job that made me the most money per hour and saved my client the most money came in data conversion. It was a win-win situation. I used to market my animal control software nationwide, and I sold my software to Sacramento, California in the late 1990s. About that time, Sacramento licensed about 500,000 dogs and managed them on an old flat file mainframe application that had a lot of weakness to it. After purchasing my application, they mentioned that they had budgeted $32,000 to hire data entry people to enter the records, that 500,000 number of records, and they were going to do that over a 3-month period of time. So that was $32,000 budgeted for, I believe it was 3 people over a 3-month period of time. Their DP department had said it wasn't possible for them to convert their existing data into my format, and they had not mentioned that to me specifically. So the challenge was that my application kept data in a lot more detail than what their mainframe application did. For example, they had a complete address in a single field, where I broke the address down into 3 or 4 fields. I had a street number, a street direction, a street name, and then I also allowed space for an apartment or a lot number. So seizing on the opportunity, I made them the following offer. I told them I would convert their data into the application format, and I would provide them at least 90% accuracy, and I would do so within 2 weeks, and I would charge them $8,000. They would pay nothing until I delivered the data and proved its accuracy. Well, it was a no-brainer, and it was a great deal on their part, and it was a good deal for me. At worst, they were going to be out 2 weeks if I failed. But at best, they would have their data within 2 weeks, not 3 months. Then they would have much better data accuracy than they would have had they had data entry people, and they'd save themselves $24,000. I had that application written and the data converted within 6 hours after I started. The biggest challenge, again, was that address that we talked about. And I used a technique that I'm going to show you in some of my demonstrations here shortly to break that address apart into different parts. And then I analyzed those parts to determine, is it the street number, is it the street direction, is it a street name, or is it a lot number? And I had to set up a series of different rules because that data obviously was entered a little bit different. Some people will put APT for apartment. Some people would put a £sign for an apartment. So rather than send that data back to them that same day that I converted it, I felt that it was wiser customer relations to wait and send it out probably about 4 days later. So what did they end up getting? They ended up getting their application then not only for $8,000 as opposed to the $24,000. They didn't have to wait even that 2 weeks. They got the application converted and ready to run within 4 days. So what can you do with a string? Anything that you can imagine you can do with a string. Aside from my typical data management responsibilities, I use strings a lot for scraping and mining data. And typically I do that off of websites or sites that make data available. It's relatively easy to pull data off a website that's based on a tab or in a table format on a screen. You'll also find that the U.S. government makes a lot of data available to you. Most of that data is in a comma delimited format that you're going to have to use a technique like I'm going to show you in order to pull that data out. The Obama administration made available to the public data that is otherwise considered public. President Obama came out and ruled and said if the data is considered public and it's maintained by the federal government, then the federal government has a responsibility to make that data available for the general public at large. So you'll find that a lot of data is out there available, some very obscure data, but some very detailed data as well that you could play with if you wanted to jump out and do the research on it. Before I go on, I want to mention string methods. First, a string, although it's a data type, is really a simple object. We know objects have properties and we know objects have methods. When we think of a string, we think of a data type, but in fact a string is far, far more than that. Originally it was simply a simple object that you put a value into. But what has happened in the object-oriented programming world is they've extended that object out and they've added methods. And that's what we're going to be talking about and demonstrating here shortly, is what are those different methods that we can use in order to manipulate those strings. In the old days of programming, what I'm going to be showing you were commands that were outside of the string. For example, in old versions of basic language or in old versions of COBOL, if I wanted to come back in and trim spaces at the end of a string, I would have a trim command and then I would include the string that I wanted to trim. Now what we're going to find is that trim is part of the string, and it's going to make life a lot easier for us because it simplifies things and it brings commands together. In the old days, now I know that when I type in string dot, I'm going to see all the methods that are available to me from that string. We will also discover at the conclusion of this lecture that you can actually create your own methods to an object. We call those extension methods. And that is an extremely powerful feature of not just of string objects, but of any object that exists out there. One of the problems that we have when we write programs, well, I don't know if it's a problem, it's a benefit, is that we create a class and that class has properties and methods, and then when we compile that class, that code is no longer available. For example, a text box that we use right now. The text boxes that we drag onto our form, we don't get to see the code that was written behind it. Somebody wrote and designed that text box, and there is actually someplace a text box class that exists. We can use it, but we can't see what's inside of it code-wise. They make the properties available to us and they make the methods available to us. But we cannot change that object per se. But what we're going to find out at the conclusion of this lecture is even though we can't change the object, we can modify it from the outside. We can say, okay, here is a string object. I want to add in a new method to that string object so I can type in string dot and have a command pop up. But I know I don't have access for the code behind it. What we will use, we'll look at a technique towards the end of this lecture called extension methods, which will allow us to add it, and I'll give you some examples of extension methods as well. So let's go ahead and get started. Okay, folks, let me go ahead and introduce you to my demonstration program that I've got here for you. What I've done is I've created a console application. So you'll notice up here is console app. Here is my main. Remember that every application that is created in the C# world or in the C++ world or in the C world for that matter always starts off and looks for a main method, and that's what the startup method is. So we run this application, main is going to automatically execute. This piece right here is telling us that there can be some values that are going to be passed to main. It's possible as arguments, but in this case there's nothing being passed to it. It's just being executed. So that is, again, optional. We'll talk about that in a later course. But let's take a look at what I've got set up right now. I've got two different strings set up, and in order to declare a string, we obviously start off with string, and you'll notice that there's two different variations of the string method. There's an uppercase string and a lowercase string. They both do exactly the same thing. One refers to the other, so they're aliases of one another. So it doesn't matter whether you type it in uppercase or lowercase, although typically we're going to do it in lowercase. So after you type in the data type, this should be review, you give it the name of the string. So if I do str example here, it's just going to set aside enough information, or excuse me, enough memory to store example in memory, but initially it's going to be empty. There's not going to be anything at all in example. Whereas if I declare it like I did down here, so I've got the variable str sale price declared, and I'm giving it the string 97.99. That's not the value 97.99. That is the string 97.99. Has zero value in it right now. I'll have to cast it if I want to get a value out of it. So let me go ahead and take this guy out. So we know how to declare a string. We can declare a string like this. We can also declare multiple strings in a line if we want to. I normally don't recommend that as a developer. I'd rather declare my strings individually. It lets me read my application a little bit clearer, but that's a technique. So again, this is declaring a string, and it's storing in it the character 97.99. Here I'm declaring a string called str phrase, and I'm storing the start of the Gettysburg Address. So it's 7 years ago, blah, 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 all the way down to the end. Okay? Now, let's continue on here. That should be pretty much review. One thing that is not reviewed, though, is how big can a variable be? Technically, a string variable can have 2 gigabytes of information stored in it. That means I could take 2 gigabytes worth of string here, or I could open up something and store 2 gigabytes worth of string inside a str phrase. That is theoretical. That is not practical. If you store 2 gigabytes, because of the amount of memory that a string requires, you're going to probably exceed the amount of memory that some of your clients might have running your application. So strings are not going to be that large. Typically, they're going to be a lot smaller than that. If you're going to have a string that's larger than that you have to deal with, then probably what you want to do is store that in a file somehow and read that, or store it in a database and read it in piece by piece if you have to. But I've never dealt with a string. I've read websites into a string before that had a lot of information, but never to the extent, I don't even think, over several megabytes in size. So let's continue on and talk a little bit about the casting here. We've already done some of this. So in order for me to do the demonstration, I'm going to start uncommenting each one of these sections, and then we'll go back in and take a look at what they do. So everything I'm doing in here is going to be in baby steps. I've got a variable here, and I'm just doing a simple parse. This should be just a review. And the review I'm pointing out here says that whatever's on the right-hand side, the left-hand side has to match it if that's going to be a destination. So if I'm going to put a value, if I want to move a value in to double price here, and it's of type double, the only thing that I could put into double price is something of type double. So I've got a string over here, str sales price, which is the $97.99. If I want to read that in and print it out numerically, then what I have to do is I have to parse it. So I'm telling it right now, take str sales price, that 97.99 character, and convert it into a double. And at that point in time, then when you convert it into a double, move that over into double price. Now again, it's assuming that str sales price is going to be in the right format. Let's go ahead and run it and see what it's going to look like. So notice what I've got is I've got the 97.99 printed out. How did that work? It did the parsing to the double price, and then I did exactly the backwards. I then, to display it in the console write line, I did a double price dot toString. So that's what you use right there to parse back to a string method right there. So let's go back and take a look at the app. Before I go on, I should mention that it paused only because at the very bottom of my demonstrations, I included a console.read key down there that's not commented out. So that's why the application was able to pause. Now, what could generate an error for me here is anything that's non-numeric. So if I put a letter A, let's stop the application from running, and let's put the letter A somewhere inside of here. Okay. So it's still accepted. It's still a valid string because it doesn't care what's between the quotation marks. And I'm not seeing an error yet, but this is going to generate a logic error when I try to run it, because what it's going to do is it's going to try to parse this into a value, and it won't be able to do that. Let's run it and see. Wait for it to generate my error. And there's my error. Notice it's a format exception error. It's telling me it's incorrectly formatted, and there's the value. So it's expecting me then, if I'm going to use a simple double dot parse, so whatever I'm passing in, it better be the right data. Let's take a look at a different example that is similar, and it's a new command I'm going to show you here. So let me comment this guy out, and let's come back to example number 2 here. And example number 2 is a pretty powerful feature, and I'm now going to do something a little bit different. I'm going to parse the data, but this time I'm going to use what's called a tryparse. Now, a tryparse is one of those commands that's really cool. I don't feel comfortable with it because it doesn't immediately make a lot of sense when you first glance at it, but it works great. Let me explain what it does. If I try to do a tryparse, what it does is it says, try to parse this value right here. And if this value is a number, okay, then allow it to go ahead and parse. But if this is not a number, then what I want it, and it's going to parse it to output here. If it's not a number, then it's going to return a false over here. So let me back up again. This statement right here does two things at once. The first thing it does is it returns back a true or false if it was able to parse it. Okay, true or false if it was able to parse it. If it's able to parse it, it's going to return the value back as double sales price. If it's not able to parse it, it's going to put a false over here. So let's take a look at that. Let me do my console write line here. I don't have one in this area. Let's add one down here. And I'm going to go ahead, and first thing I want to do is I'm going to print out is good. Let's just take a look and see what is good returns back. And folks, where this is going to be powerful is this lets you look, first of all, to see is a value in there the correct value a person put in. If it's not a correct value, you can then do an if then else statement on is good, and if is good returns a false, you tell the user they did the wrong input. Let's just take a look at this. So I'm going to do an is good, that's Boolean, so I need to do a toString on the end of it to print it. And let's just run this. So I'm passing into it. Let me come back up here. And what I'm going to do is, I think let's pass into it this 97.99 instead. Well, I've got that 97.99. So I'm reading the 97.99. If it's able to parse it, it's going to then put the value in double sales price. If it's not able to parse it, it's going to make is good false, whereas is good would be true. So right now I would expect to run it, because that is a valid number, I would expect is good to print out true. Let's try that. It did. It printed out true. Now let's come back over and let's put that A back in here. Okay. Now what happened before was it generated a physical error that stopped my program from running when we did a standard parse command. But now this time what it's going to do is it's not going to stop my program from running. Take a look at it. It's going to return back a false. So that false statement right there that it returned back told me that it's not a valid entry. It didn't give me an error like it did before. So let's do one other thing here. Let's see how double sales price looks. Let's copy this out. Let's put double sales price right here. And I'm going to do a toString method on the end of it. Take a look at what's in it. Now, if when I run this, double price will come back, I would expect it to come back as a 0 right now. Why would it come back as a 0? Because I start off double price valued at 0. And then on the next line down, I say, now try to parse in this 97A.99. If you're capable of doing that, then change the value of double price to whatever it is. If you're not able to do that, then put false over here. We're bypassing the false. We're not going to look at that. We just want to look at double sales price. So I would expect it right now to fail and to leave it at 0. Let's see. It left it at 0. Now let's come back and make that correction up here. Okay, now let's rerun it, and I would expect now that it would print out 97.99 as it did. Now, of course, what I could do is I could leverage this is good right here. Okay, so I could say something like if. Now remember, is good returns back or true or false. So I could say if is good is equal to false, something like that. If it's equal to false, I could write that, but that is redundant. What does it mean it's redundant? Because is good already holds either a true or false. So if it's true, it's going to do the true portion of it. If it's false, it's going to do the false portion. So right now, I want it to tell me when it's not good. Okay, so right here, I'm going to put a if it's not good, okay, then I'm going to print out maybe, let's print out error. Okay, else, let's print out the number. Now, notice I don't have my brackets in here. Why do I not have brackets? Because I have only one statement underneath it. If you feel more comfortable, you can always include the brackets. It makes no difference. Brackets only required when there are more than one statements inside that loop, right here, or inside the if statement, I should say. So if it's not good, I want to print out that there was an error to the user. But if it is good, I simply want it to print out what the new value of double price is. Oops, let's try that again. Double price, copy, and then paste, and then toString at the end of that. So let's see what happens. Let's play computer first. So it's going to set double price to 0. It's going to try to parse double price into double sales price. So in this case, it's a good number. It should work, and I should get double sales price down here to print out on the screen. So it's a way to test it out. Let's run and see. There's my double price. Now let's, again, just to play around with it a little bit, let's put an error into here. Let's put an X in front of it. Okay, and let's rerun it and see what it says. Error. So that tryparse is a really cool command to use. It's really nice, but you typically will use it in conjunction with some kind of an if-then-else statement to try to determine was it successful in doing the parse. This is another method other than the try-catches that we talked about previously, perhaps, hopefully we've got through that lecture already, in handling errors. There's a lot of different ways to handle errors, and this is just one of those methods. Let's go ahead and comment this guy back out, right here. And get the X out. Let's take a look at our next example here. Example number 3. So example 3 is going to be using concatenation, and I'm going to use a couple of different techniques just to show you concatenation because we've already experienced it before in the basics of C#. So let me go ahead and uncomment this, and let's take a look at what I've got here. I'm creating 2 different strings at this point. String part 1, I'm putting Spokane into it with a comma and a space after it, and then I've got string part 2, I'm just putting Washington in. Now, one of the ways, probably the more traditional way that we learn, and this is probably should be at the top, not the second one down, let me move this up here, is this method. And all we're going to do within this method, oh, what did I do here? Oh, this is part 4. So I'm going to put it back the way it was because I may have an order issue here. So let's first of all talk about this guy. This guy, all he's simply doing is says take str part 1, Spokane, comma, space, and add to it immediately after that the WA. So I would expect that when I print out str part, that says part 4, this should be part 4 here, that when I print out str part 4 using this method right here, I think that should be part 5, that I would get Spokane, Washington. Here is another method for doing exactly the same thing. So all 3 methods I'm going to show you do the same thing. This method says take str part 1, and this is like saying str part 1 is equal to str part 1 plus str part 2. Excuse me, str part 3 is equal to str part 1 plus str part 2. And what this says is, right here, add to the end of str part 1, str part 2. It should do exactly the same thing. And then this last one is the first method that we're going to take a look at that belongs to string. String has a method in it called concat. And let's take a look at where we've got. If I hit a period at the end of that, we're going to see the methods, a lot of the methods that we're going to be taking a look at in here. And what concat does is it just simply says add these 2 methods together and then plug it into str part 5. So it says take part 1, add in part 2 to part 1, make that new part 5, and then I'm printing out part 5. So I want to make sure everything is working out correctly here. Okay, let's go ahead and run this and see what it looks like. And you'll see, I got Washington printing out on these bottom 2. Let's go back and take a look at why I got a duplicate Washington printing out. Oh, and I'll bet you it's because, yep, let's see here. So str part 1, I want part 3 to be equal part 1 plus 2. That becomes part 3. Then I want str part 4 to be part 1 and part 2 becomes 4. And then part 5. Let me take a look at this. And I can see right here where my mistake was made at this point. What this guy is doing is, as I just mentioned it to you, it says take str part 1 is now equal to str part 1 put part 2. This guy right here modified what str part 1 was. So really this method really was in order to concatenate part 2 into part 1 and make it the new part 1. So really all I really needed to do is this. I've got way too much in here. I could have done this. Since part 1 was already declared up above, I could do this and just print out part 1. So this is saying str part 1 is equal to str part 1 plus part 2. And then I have the same exact issue down here because part 1 now was changed up above right here. That's what's causing this problem where I've got the Washington printing out at the end. So again, let me show you what it's going to look like. I've got the two Washingtons. If I come back in here now and I simply comment out this guy, which is modifying part 1, now I rerun it, now I get the Spokane Washingtons. So 3 different ways. Which is the best method for you to use? The best method is the one that you like the most, the one that you're most comfortable with, because they do exactly the same thing. So let's recomment these guys out again. And let's take a look at the next example. So in this example, what I want to do is I want to loop through a string as though it's an array. Now, we don't think of a string as an array, but the fact is a string is a technical array. And in the programming world, or in the object-oriented programming world, I should say, when we're talking about something like this, an array of objects is what's referred to as a collection. So we have an array of data, and we have an array of objects. An array of objects is a collection. So technically, this is making a collection. But let's take a look at what it does here. So let me go ahead and uncomment this guy out. And what I want to do is I want to loop through that array. I've given you 2 different ways that we can loop through the array, 2 different for loops in here. So let's take a look at the very first for loop and see what it's doing. So in this one, remember, a for loop starts with what's the initial value, what is the value that stops the loop, and every time it loops through, what's it supposed to do? It's supposed to increment I by 1. So the first time through, I is equal to 0, then I is equal to 1, and it's going to stop only when it gets to the end of whatever str phrase is. And remember, str phrase is this long phrase that we have up above here. So what I wanted to do was I wanted to loop through it like it was an array. I want to read each character individually out of it. So I start with the 0th character because we're geeks and we always start with the 0 item instead of the first item. And then I'm going to increment that by 1 each time. So let's just take a look at what the output's going to look like. I'm going to get the output for this one as well, but we'll come back and talk about that one in a minute. This is a much easier one to understand, I think, but we need to understand both of them as well. So let's take a look. So notice what happens. It took that entire phrase of the Gettysburg Address and it plugged it in over here, and I did 1 character per line. So how did I end up doing that? What I did is I did a console write line for each individual character. So here's what happened is it grabbed str phrase and it said grab the 0th character out of that string. That's the leftmost character. In fact, let's pause this. Let's go ahead and run through it and see it act. Let's rerun it again. Okay, so we're sitting on this line. It's now initializing our for next loop. So let's let it go through that process. Right there, boom, it set I to 0. If I point to I, I'm going to see I is 0. And by the way, these variables are local only, even though they're not defined within these brackets right here, the scope of this I is only within these brackets right here. Okay, so now, I set it at 0 initially. We see that it's set at 0, so I'm going to step through it again. It set the rule on it, and it knows then the length of that str phrase, and we're going to look at this one. The length returns back how many characters are in that phrase. So there's 176 characters across in that phrase. So that's what it set the loop at. Start at 0 all the way to 176. And every time you run through this loop, start at 0 and add 1, what's going to stop the loop? When I is greater than 176, when it's finished with everything. So then it's going to print out that first item. So let's see what happens here. So if I step into here, right here, it's not done that line yet. Let's find out what str phrase is equal to. Str phrase is the for score, but if I grab this statement right here, the toString statement, and I add that to my watch window, let's go ahead and add to my watch window down below. Let me get rid of these old watches in here that are outdated. You'll see that the F in for score was the first thing it read. So let's run through this again. Let's step down. So it's going to print the F on the screen, which it did. I don't know if it'll let me see it or not. Yes, it did. There's the F on the screen. Now the next thing it's going to do, it's going to grab the next character. Okay, so now I is being incremented. It hasn't incremented yet, because if I point to I, it's going to tell me that it's still 0. But now it's going to increment the I right now. The moment it increments I, it's then going to say, is that new value of I still within this range? If it is, write it out. If it's not, you're done. Jump over it. Let's take a look at it. So it's incremented it. It now wants to know, if I look at I's now 1, it wants to know, is 1 less than 176? Yep, even in new math, 1 is less than 176. So let's step down, and it writes that second item. And let's go take a look. And then there's a second one, the O and 4. So as I continue on, let's take the stop out of here and let's just run it. It's now printed everything out. Now I'm doing it 2 different ways. There is all the data down here. It's printing out twice, once for this bottom one as well. So I think it's really important, folks, that you go back in. If you don't already have that gut understanding of what a for next loop is, it's important to understand exactly how it works. Starting value, what the rule is that tells it how to stay in the loop or when to jump out of the loop, as well as how to increment over here. Now let's take a look at this guy. This guy is going to deal with it as though it's a collection. This is how we deal with a collection. So what it says is, over here, for every, and I like to think of this as a stack of plates, folks. So it sees this str phase as a stack of plates now, and every plate represents a different character that's in str phrase, all the way up and down. And you can grab one plate off at a time. So that's what we're doing here. So let's come back in and use that example in this. So I'm going to put a stop over here, and we'll take a look at what this guy does. So the first one's already printed out. If I go back in and take a look, that whole loop is printed. And if I look at the output, there is all my output, pardon me, from that first loop. Okay. Now, let's go ahead and close that guy out. Let's look at this for each loop down here, and we're going to rerun it. Okay. So we're starting a for each loop. Here is str phrase. It's that giant phrase. But now I'm going to tell it, every time you see a different character in that phrase, grab a character off and call that character C. So the first time it jumps through, it's going to see the F and 4 score, and it's going to grab the F off, and it's going to print the F off. Then it's going to loop back up, and it's just going to see a giant stack of letters that make up str phrase, and it's going to grab the next letter in order. This is a much easier method to run than using this one up here as far as understanding it. It works better, but this only works when we're dealing with a collection. Some arrays, you have to know the beginning and ending point. This is a little bit different here, but it works very well. So let's step through it and see what's happening again. So it's grabbing one character. We haven't talked about the char data type yet, folks. We're going to experience that in a couple of places in the examples below. Char represents a single character. Just one character. You can only store one character in char. Don't confuse this with the char data type that we might have in SQL. This is different. This says a single character. If I try to store a word in char of more than one character, it's going to give me an error. It says you can't do that. You can put one letter in char, and that's what it's doing right now, is it's grabbing one letter each time out of str phrase, and it's just going to print it out on the screen. Can't get much easier than that one. So let's prove that again. Step down. Okay. It sees the end statement. It's going to grab the C out, and it's grabbed that C right now. Let's see what it grabbed. It grabbed this case, the F. And by the way, notice that 70 to the left of that, that's the ASCII character for the ASCII decimal value for F, which is the value 70, I believe. So we just keep looping through this thing, and you just watch it now. It's just going to keep looping through, grabbing a character at a time, and writing it back to the screen. And when it's done with all of them, it will then, because I have that pause, it'll come back and show it to me on the screen. Extremely powerful, folks. We'll see this over and over again, not just in the C family, but in most all other languages have a variation of that. Let's go ahead and comment this guy back out again. And now let's take a look at splitting a string into an array. Now, this is kind of strange because I just got through telling you that an array or excuse me, that a string is a type array. It's a type of collection. That's not what this is saying. This method says I want to take a phrase and I want to split it out. I want to break it apart. But in order to do that, I need to tell it what character I want to break it apart on. This is very powerful. I use this all the time. In this case, I'm going to break that giant statement out, that the start of the Gettysburg Address, by spaces. And then once I break it apart by spaces, then I'm going to use that for each method we just talked about to print it back onto the screen, but by word. So I'm breaking it apart by word, not by character here. So let's uncomment it and let's just look it over. So first thing I'm going to do is I'm going to create an array. And the array is called words. We talked about an array before. An array is just like a variable. It will hold multiple different values. So now the next thing I want to do is, once I get that, I've got this guy created. That's going to be my ultimate storage location where the words are going to go. On the right hand side now, I've got my phrase, and notice now I'm going to use a method of the phrase, and that's the split method. And one of the unique things about split is you pass it a character that you want to split, and that character is going to be of type char character. Now, I need to mention one thing, and that is anytime you refer to type char, you use apostrophes and not quotation marks. So what I'm telling it right now is I want to split it based on a space. And really what it's going to do, I want to take every word and it's going to look and say, well, 4 is the first word, score is the second, and is the third, and it's going to store those individually into an array. And there's a lot of uses for this. So let's just take a look at what's going to happen here. Let's run it and see. So I've passed that line by. It's now split it. It's run this line, and let's see what words has in it. It says it has 30. There's 30 different words in that statement. Let's open that up and see what the words are. And here it is. See how it was all broken apart by spaces. Now, another place that I use this often is you will download data that's comma delimited data, and you need to break that comma delimited data apart. What you do is you break it apart not by a space, but you would break it apart by a comma. It's not going to let me do that because I'm running the program. So you'd put a comma in there, and that would break that data apart using that particular method. So let's continue on and see what's going to happen here within our demonstration. So it sees words. It's now going to grab the first word out. What word did it grab? 4. Then it's going to print that out to the screen. And let's go back and double check and see if that's what it did. There's my 4. And the next thing that it's going to do is score. And so on until the entire loop is printed out. You see, here's every one of the words. And notice that the comma was included within the word because that was word, comma, space afterwards. So maybe later I want to go back in and strip out those commas. We'll take a look at a method here shortly that we might use in order to get rid of that comma inside all of these different strings. So one more time I want to review it. What I did here, I used the str phrase split command, and the split will allow me to convert that phrase, str phrase, into individual words by breaking them apart between spaces. And I'm using a to-list method at the end to store it into my array over here. This just makes it a lot easier. There's other ways to do it than this, but this is by far the easiest way to move it across. Now I have words when this line is run for the entire start of that Gettysburg Address. And I'm going to go word by word. So I'm going to, and I could put anything in here by the way I want. I just called it word. I could call it X right here, and it makes no difference. That's what I created. Still does the same thing. So, but it makes more sense to say, look, grab me the word inside words. That's just a technique. Sometimes you'll have plural over here and singular on the left-hand side just to make sure it makes more sense. Hopefully this helps. Let's go ahead and try the next example. So this one, we've got, this is just a really quick way of going back in. It's a new string method that lets us test to see is that string empty or is it null? Maybe we require the user to fill something in. We want to test once they filled it in, and we want to reuse this. We may use it in the condition of null, we may use it in the condition of empty, or maybe either one of the two. We just want to make sure something is in this phrase. So let's uncomment this guy and take a look at what it is. So when I run string and I got is null or empty, and I pass a string into it, it's going to return back a true if it's null or empty. It's going to return back a false if it's not. Okay, so let's take a look at this. So we know that there's something in that string up above. Let's run it. It's not empty. Is it? That's what it's asking. Is phrase empty? It's not. Now let's come back up here and let's do a little bit of manipulation here. Let's put an empty quote here and a semicolon at the end of this, and then we'll comment the rest of that line out. So now it's an empty string. Let's rerun our code and see what it says. It should return a true. And it does. So it's a shortcut way. We could have done this before. Actually, I could have done something like, I could have said if str phrase is equal to null, or str phrase is equal to nothing, then I could have come back in and said something to the extent, and I could have done exactly the same thing. I would have set check equal to, and I used or. Let's try doing it the right language. So I could then have set check equal to, if it is equal to null, I would set it equal to true. Else I would set it to false, and it would have done the same thing that we get up here. So it's a shortcut command to do it. Let's go ahead and I'm going to take this code out, and let's take a look at the next example. Searching a string. Oh, this is a really cool one here too. Try all the way down here. There we go. Uncomment that. Okay, so what we've got is a str phrase index of. So we're going to take a look at a couple of different commands in here. Index of will tell me within that string str phrase what is the numeric location starting from 0, like that array did, of the word score. Where is score located at? I'm going to store that location in int location here. If there is no score up here, it's going to put a -1 in int location. And right now, I believe there is none up in there. I've got it empty, so I would expect at that point that it would print out a -1 based on what we had. Down below here, I'm looking for the last index of. What that says is there may be multiple ands in your statement, but I only want to know where the very last and is in your statement. Pretty powerful there. And now let's take a look at this next one here. In this next one, I'm creating a variable called str website. And what I want to know is this a HTTP website? So I'm going to use the string of what we've got, where the website is located at, str website, and I want to know, does it start with http://? It's going to produce a true if it does, it's going to produce a false if it doesn't. So I could be passing in, for example, reading somebody's entry for a website. I want to determine, did they give me a valid HTTP website? I want to know that it started with http://, and I want to know that maybe it ended in HTML. So it ends with or starts with. And then I put down here just simply on the screen, HTTP site, true or false, HTML site, true or false. Let's run it. I would expect right now it's going to come up with false for everything because, oh, wait a minute. No, I'm not using the string above, so it's going to work out. It should work pretty cleanly right now. So initially, I will get 0 or -1 for score, -1 for and, but down here, these will give me some different outputs. It will tell me true that this is an HTTP website and true that this is an HTML website as well. Let's run it. There's my -1s because I didn't find those strings above. And is an HTTP website true? Is an HTML page true? So now let's change this around a little bit. Let's say one of the weaknesses in this is that we might have a secure website. That might be an HTTPS website. And let's go back up above here and also put this back the way it belongs. There we go. So back in our demonstration now, it should tell me the location of score in it, and it will tell me where the last end is located in that statement up above. And then down below here, I should find out now that neither one, the HTTP website should return a false to me, but it still is an HTML page. Let's run it and see. There we go. So the 5th location is where the word score is. At the 112th location of that string is the last end statement. Because remember, fourscore ends 7 years ago, the end statement. There's one at the beginning, and there's several of them within a string, and that's just the last one. So easy commands to deal with and very powerful. Where all this stuff comes in power, folks, is when you use them within each other, not just one at a time, but in conjunction with one another. Here's joining the strings from a collection or an array. So now this is going to be something a little bit different. We're going to use that example that we did up above. So let me come over here. Let's uncomment and see what exactly this guy's doing. So I'm creating that array of words that we did before, and I'm breaking it apart by spaces. And that's from that example 5 that we had up above. So I've already done that. Now I'm going to do the opposite though. Now that I've got it split, I want to show you how to reassemble it again. So now I'm going to take a string.join, and I'm going to join words together that it broke apart here, but I'm going to join it with spaces in the middle of it. Now, I believe that's looking for a type. Because I can put more than one character in there, notice the difference. Here, I'm splitting it by type char. Here, though, I'm doing it with quotation marks. What's the difference? This one allows me to put multiple characters in. This one expects only a single character. So what I want to do now is I want to see what that string is going to look like after it's reassembled again. It should look exactly the same as it did the first time. Let's find out. And there it is. Fourscore and 7 years ago, all put back together. And if I wanted to put it together differently, let's put it together with pluses. Reassemble it. Run it. And you'll notice a plus in between each one of the words. Or if I had to be giving this out to somebody in a comma delimited format, there's my comma delimited format. Everything's separated by commas. So reviewing it again, this statement broke the list apart into words, as we did above. Then I took those words and I said, I want to take each word and assemble them back in the order they're broken apart. And in this case, I did it with a comma. I did it initially with a space. And then I simply printed that joined string out, the new variable I created right here, in the console. Pretty easy. Selecting a piece of a string. So in this case, we're going to take a look at that substring method that we talked about earlier. And the substring method is really powerful. It's got two major features to it. First of all, substring starts, and the first character says, where in a string do I start? This says start at the 31st location, or 0 to 30. And so I'm telling it, I want to start the 30th location and give me the rest, since there's no argument after 30, give me the rest of the string. So it's going to go to the 30th location, grab that character, and all the way to the end of that string, it's going to grab everything out, put that back in to strpart, and then it's going to write out strpart. This next one is going to do the same thing. It's going to start at location 30, but a new argument comes up that says, how many characters past that should I read? So this is going to start at 30, and then it's going to read the next 20 characters, or if it runs out of characters, it will stop. It won't error, meaning that if I started at 30 and there was only 35 characters, it would just show me the first 5. But I'm telling it right now, I want the next 20 characters shown, and I want to put that also in strpart. Now notice I'm using the same variable. How can I do that? Well, because here I create it, I show it, I'm really technically done with it, and I'm just using that same variable again to put a new value into it, and then I'm going to show that new value. Let's run it. And here we go. There is the output. So here our fathers brought forth, so it lost that 7 years ago at the beginning of it, because that was the first 30 characters. It started at the 30th character and went all the way to the end for that one. And then on this other one down below here, where did it start? Let me comment this guy out here so we're not looking at it. Let's comment that guy. Let's rerun it. Uh-oh. Can't do that because I gotta leave this here. Let's rerun it. Just get the final output. Our fathers brought. So there would be the 20 characters right there that were taken from the inside of str phrase. Again, I use this one constantly. Let's take a look here at example 10. So example 10 is converting a string from to upper or lowercase. And it's just as simple as you see right here. You've got your string, and right after it you can convert that entire string to uppercase, or you can convert that entire string to lowercase. I'm not rewriting, by the way, str phrase here. I'm just saying for output purposes, output it. Str phrase is still going to be in the original format it had. Just for output purposes, is it going to convert it to upper? Just for output purposes, is it going to convert it to lower? And let's see what we end up with. So the first output to upper is our 4 score. There it is in upper. And then our second one was to lower, and there's everything in lowercase printed out. Pretty fast and cool. Example 11. Lots of examples here. So now we want to count the occurrences or occurrences of a character in a string. So I've got this statement, and we're not even counting here. I'm actually going to replace it, so that's not even worded correctly here. Let me pause this and fix this. Okay, I've got this a little bit corrected. I had the wrong title up here. So it should replace the occurrence or occurrences of a character or characters in a string. So this is kind of like a search and replace that exists inside of a string. So I've got that str phrase up above, and what I want to do is I want to find 4 score and 7. Nobody knows what that means. A score is 20 years, and I want to replace it with what it really means, 87. So 4 score and 7 really means 87, and then I want to print that out. Now, another thing that you can do is remove things. So in this particular case, I'm going to go back to that same str phrase that we had now, and I want to go back in and I want to replace all the spaces with nothing. Notice what I'm getting. Basically, I'm eliminating all the spaces within that string. Again, very, very powerful to do that. Let's run this and see what this is going to look like. So first thing is I replaced the 4 score and 7 with 87, and that's what I ended up with. 87 years ago our fathers brought forth upon blah blah blah. And then on the next example down below here, I said take str phrase and replace all the spaces with an empty string, with nothing, and that's what I ended up with. Is the entire string that we just created has no spaces in it. Now, this actually replaced str string, by the way. I rewrote str string without spaces, and that's why it's placing it here. I could have, let me show you what I could have done. Could have done this. If I didn't want to replace str phrase to begin with, I could have done this. Let me comment this line out. Let's take this string right here, and I could have done this. So now, remember, it runs the inside first, so it's going to go back to str phrase, and it's going to replace all the spaces with an empty string, and then it's going to right line that. Now, this will not change the original str phrase as though this guy did here. This is just going to give me the output. There it is right there. This next example allows us to go back in and insert characters within our phrase at some point. We're not changing characters, we're just actually going to a certain spot, spreading open that string, and adding in new characters. So the way this statement reads is str phrase dot, and remember again, where do these come from? You hit a period, and it's going to show you all the different methods that exist within that string variable. So here I'm inserting at the 43rd location and mother's space, and then I want to output that. Now I'm rewriting str phrase, so I'm re-establishing a value of str phrase here. If I didn't want to do that, I just wanted it for output purposes, all I needed to do was put that within here. But let's just take a look and make sure it works. 7 years ago, our fathers and mothers brought forth, and that's where this came from, right here. Pretty easy and very powerful. Again, as I mentioned, where this gets much more complex perhaps is when you start doing these in conjunction with one another, because they can be daisy chained. When I say daisy chained, watch this. I can come back over here and say str phrase dot to, let's see, what would I do? I could say trim, and then once you get that item trimmed, then I want it to become uppercase, and I can continue to keep putting these on each other. So in this case, it's going to trim str phrase, and then, well, you wouldn't two-string an str phrase, but you see what I'm getting at. You can keep doing these back to back. You don't have to do them individually. But obviously that does make them look more complicated as well. Let's take a look at 13 here. 13 is the trim command. This is one of the ones we talked about before. So what I want to do is I want to trim the lead and trailing spaces. So sometimes when you go back in and you read data, that data has some problems. It has maybe a space at the beginning of it, a space at the end, and you need to clean that data up, cleanse that data if you will. And a trim command is one of those that we would use. So what I want to do right now is if I come back in here at this point and I type in str first plus str last, I'm going to get all of these spaces included when I concatenate these two guys together. So it's going to be space, 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 Fred, space, 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 then all these spaces, then Flintstone. Now, when I come back below here and I trim it, it's going to take all the spaces off of both of these guys and then plug them in together. This is actually not going to be the best because I'm going to lose the space at the beginning, but it makes the point here of what it is intended to do. So the first one, as I mentioned, just plugs it in, it concatenates it, and I get everything together. What I really want is those spaces taken out, and I can simply use the trim command here. And the moment that I use trim, it's going to trim both left and right spaces as they exist out and plug everything together. And look what we ended up with. Fred Flintstone all together. So trim is pretty powerful. You use it generally when you're importing data. Oops, let's cancel this. There we go, get that canceled. Let's get rid of 13 here. And let's take a look at padding. Padding is one that I've used several times in business applications, but I don't use real commonly, but I could see where it would be of some value. So let's uncomment it. And so we're going to start off with a double check amount, and that check amount is 4767.88, $4,767.88. Now, the next thing that I want to do is I want to come back in and I'm going to take that double check amount, I'm going to convert it to a string, and I'm going to make it concurrency. Now remember, a minute ago I showed you I can daisy chain these together, so I do the two-string method, and then right after that I'm telling it to pad, and I want to make that entire string 12 characters wide. Right now it's 1, 2, 3, 4, 5, 6, 7. So there's 5 additional characters now that it needs to fill in stars with. And that's what pad left does. Pad left goes back and puts the stars. This is an example of where it might be of value. Maybe you're writing out a check to an individual, and inside that check you're writing to the individual, you want to do stars to fill left. So let's take a look at what that might look like. So notice right off the bat, let's see how it came up with this. I've got star, 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 and then I've got the dollar sign, and I've got the amount formatted out that might go on a check line if you're writing out a check. And how did it do that? Well, what it did is it went back in, and the very first thing it did is the two-string conversion, and it ended up with this amount right here with the dollar sign on it. Then once it did the two-string conversion, the next thing said, look, make this whole string 12 characters wide, a width of 12 characters maximum. That's exactly what you got, 12 characters across here. And anything that's a space on the left-hand side, make it into a star. Pushes it to the left. So that's an example of padding right there. What this guy does here is he's just showing you the structure of the pad left command. The pad left command says, I want you to pass into me the total width of what you want the string to be, and then I want you to tell me what the pad character is. And notice the pad character is type char, so you'll see the apostrophes around it over here, as opposed to quotation marks as you see here. Why does it allow quotation marks here? Because I'm allowed to put in different formatting options in here, whoops, whereas I'm not allowed different options over here. It's a single character that's being passed in. Let's take a look at this example. So now we're using a format command, folks, and this is an extremely valuable feature when you want to format a string out and you want to make a complex string simple. So let's start off and take a look at what I've got here. I'm going to use that example of what we used just a moment ago for that string amount in here. So first thing I'm going to do is I'm going to set a double check amount, and that's going to be that same amount, 476788. I'm going to put the person's first name in as Fred. I'm going to put the last name in as Flintstone, not Flintstore, here. And now what I want to do is I want to format the output. I want to make it so that I have some nice clean output, and I don't want to have to concatenate, because what I could do is I could concatenate and say, okay, plug pay to the order of in, and then plug in Fred, and then plus a space, plus Flintstone, plus in the amount of, and then concatenate to the end of that, double check amount, dot toString, and it's a pain to do that, but I could do it. It's one method, but there's a better way. And the better way is to use the string.format command. And what it does is it's got string.format command starts off with the format of what you want your data to look like. So what I want it to say is pay to the order of, and the name, first name, the last name, in the amount of, and then I want the third amount to be plugged in. Third amount to be plugged in. So in this case, I use placeholders in my string. So I start off with the string that I want, and then I plug placeholders. My placeholder always starts with a curly bracket, ends in a curly bracket, and the very first item will be 0. So I'm saying take the 0th piece of data and plug it in here. Take the first piece of data, or the number 1 piece of data, plug it here, and the number 2 piece of data and plug it in. Where does that data come from? It comes from the next argument. Here's my first, my second, and my third. So what it's going to do is it's going to take this str first, and it's going to plug it in where that 0 is right there. It's going to take str last, and it's going to plug it in where that 1 is, and then it's going to take this double check amount toString. So here I'm using that same method we had up here to format that string with the padding on it, and that's going to plug all of that in for the third argument, which is this guy right here. Let's run it and then see what it's going to look like, and a couple of changes that we can make to it. We'll play with it. So if I run this out, it says pay to the order of Fred Flintstone in the amount of, and we have our information laid out just like that. Now, one thing I do want to point out is the flexibility of this guy right here. Notice that I passed in the data that was formatted here. And the reason that I passed in the data is because I was using this pad method that is only available here. But let me get rid of that pad method and show you something else that I could have done, not quite exactly the same, but very similar. So let's get rid of pad here. And I think I got an extra. Let's see, what am I missing? I'm missing, is that bracket right? What am I missing here? So I got my starting parent, 2 opening parens, and then 2 closing parens. There we go. There's the problem. So now I'm going to run this guy again, and he's only going to give me the output formatted, but it's not going to put the left fill with the stars into it. Now, I did that with the data that was passed in, but there's another way of doing exactly the same thing. So let's go ahead and take the formatting out here. Okay. And also, notice another nice thing is it didn't expect me to cast it. It didn't care that it was cast. It took this double value and plugged it right into that 2. No casting was required. I could have done a 2 string at the end of this and it wouldn't have cared, but it wouldn't have cared. So just keep that in mind. Now what I can do over here is right after this 2, I can give it some formatting. If I put a colon in here, then I can come back in and right after that put what I want the formatting to be. Maybe I want that to be currency with no decimal places. Okay. Now what that will do is that's going to take my dollar amount up here and drop the 88 out because I'm giving it no decimal places for the output. Let's just run it and see what it looks like. There it is. Now notice what it did do though. It rounded it to the nearest whole dollar when I did drop it. That was a nice feature that's built in. So what kind of formatting goes here? This is the same kind of formatting we could put on the toString method. You saw that just a minute ago. So I could do here dot toString, and I could have put that C0 right here, just like that, and then not have it here, and it would have done the same thing. Which is the better method? Well, the better method is whatever your team tells you to do or whatever you feel the most comfortable with, because they do exactly the same thing. Now we're going to talk about making up our own extension methods. So when I go back in and I look at that string, let's take a look at the string that we have here. Oops, let's go below here, and if I do str phrase and I hit the period, I can go back in. I see I've got a substring in there. I see that I have my 2 lower method or 2 upper methods or 2 string methods in there. But one of the methods that I don't have that I might like is maybe a left method. Maybe that's the one that I'd like. The other one that we don't have a string.left, we don't have a string.right method, and the other thing I don't have in here is a string.proper method. And a string.proper method is a method that I might want to use that goes back in and converts my string into a proper. So I would want to have every first letter of this string uppercase and all the rest of the characters lowercase. They don't exist in here. Does that mean that I'm out of luck? Does that mean that I got to go back and contact the person that created that string object and ask them to add those in? No. There's 2 methods that we could use now, and this is very important to understand, to add those features in. If we had the original code that that string object was created on, we could go back in and add our own method in that string object. But the creator of that string object doesn't want us to do that. They don't give us the code to go back in and modify the inside of the code and add permanently that proper or left or right method. So we have a choice. We can't add it into the object, but what we can actually do is fool the object and add it as what's called an extension method. We can add it on the outside of that method so that whenever we use string, there will be a left, there will be a right, and there will be a proper on it. Let's take a look at how that is done, because that is probably one of the most powerful topics that I have within this lecture, is adding your own. So first thing I want to do is come back down here at the bottom and let me uncomment all of this. These are the extension methods that I created. And let me show you exactly what they do. Notice that they're outside of my class. So if I was to click here, my class ends right there. I'm in the same namespace, so I'm above the bottom bracket, but I'm not part of the original program that was written. I am adding an additional feature to the program. So if I come back to the bottom of this, outside that bracket, and I do something like this. I create a public static class and I call it extension methods. And inside that extension method now, I'm going to create this little chunk of code right here. This chunk of code, let me explain how it reads, and you'll understand a lot more about it when we get into creating our own classes. But what I'm doing here is I'm saying I want to add in to the string method a new left property, the new left. And I want to take the current value of whatever the string is here, and I'm going to allow for the user now to come back in and pass in a length. So this part here is hidden behind the scenes. It says when you call the left method, pass in the string that you're dealing with. That's behind the scenes. You'll never have to do anything with it. But expect that the user is going to pass in a length. So think about it. If I say I want left, what do I want? I want the left 5 characters, the left 2 characters, the left 10 characters, and that's what this does. So then in the code down below, I tell it how to do that. I'm going to tell it how to come up with left, and I'm going to use an existing method of a property. So when this is called, it's going to pass the string in as value down here. Okay, and this is set, this is fixed. I don't want to change that. I want to leave it like that. So if I'm going to declare a method, I'm always going to do this. I'm always going to tell it which one it's being attached to. Is it a string data type? Is it an integer? Is it a media player? It could be any of these things that I'm extending out. Okay. And I'm telling it then when I call it, it's going to use the current value of the string that it's calling from and expects to receive some kind of an argument, a value passed into it that's going to be length. Now, how do you deal with that? Value is the string. Now, this would be, in my world, I'd probably call it str value, but they don't want me to change the name of it here. This is kind of like a fixed tool that we use. So I'm going to say, take that string that we're part of, that was passed into it, start at position 0, and give me that many characters from position 0. That's creating a left command for me, and then I just simply want to return that new string when it's asked for. So how do I call that up here? So let's take a look at this very last example here. It's not my last, it is my next to the last, this guy right here. And I'm going to uncomment these guys. And here is the left command right here that we're dealing with. Let's comment these guys out for right now. And notice now, if I was to take these guys out right here, I would get an error right here on this statement saying there's no such thing as left. But right now, left exists. Where does left exist? It exists because it was added now to that string, right? It was added to the string data type, and there's a new left command there. And I would expect it now to give me the first left 100 characters, the left 100 characters of that Gettysburg Address. Let's take a look at it. And there it is, the left 100 characters that come out. So I've created a brand new command. Now, I want to reiterate one thing. I'm not permanently attaching this new extension method, this left extension, to strings from now on and into the future and for every place I ever go. It's only going to impact this program that I'm working on. It's not going to impact any other program out there. Now, what I could do, though, is if I wanted to add this, if I have a large program out there and I want to add this to all string methods in all my programs, then I could create an external class file. I could do something like this. I could do a right-click, add in a new item, or I could click class down here. And when I add a class in, then I could take and make this entire class part of an external file. So just like when we're doing CSS, when we have an external file, or JavaScript, when we have an external file, for those people who have taken those classes, we can do the same thing here, and by putting in an external file, it affects the entire your entire application as long as it's in the same namespace. And what's the namespace here? The namespace right now is strdemo, which is the same name of our application. That's the default namespace. Anytime I create something new, it's going to want to plug that in to that namespace. So let's jump down below again. Let's take a look at another example of one. Here I've created the right method, and the right method is a little bit different. I want to take the right number of characters from a string. So you remember now that the substring method has two arguments. One argument is the starting location, and the other second argument, the optional argument, is the number of characters. Notice that this is one argument right here. All it's saying is if the person says I want the five right characters, then take the length of the string, let's say it's 25 characters, subtract 5 from it, 20, and give me from the 20th location to the end. That's going to give me the right method that I might want, grabbing the right number of characters. So let's take a look at that one. So I want the right 100 characters. Let's comment out the first one. And if I run this guy, I get the right 100 characters off my string. So a brand new command. Again, it only works in this application right now. But as I mentioned earlier, one of the things you as a good developer will do is you're going to start creating classes where you do these extension methods, where you create your own methods that you know you're going to want to reuse over and over again. And you're going to add that into every single program that you create. How do you do that? Well, if you've got a feature, you can just simply do this. Do a right click. You can say add in an existing item. And you can add existing items into your application, and that could be an external class. And just simply by adding this class in, you have all these features that you just created on your own. Let's take a look at the very last one, which I think is the most impressive one of the group, and that is the proper command. So what I want with proper is I want the first character of every single word to be uppercase and the remaining characters to be lowercase. Why would this be important? Well, me in a database world, I typically like to store all my data on a server in one format. Everything is going to be in uppercase. And the reason I do that is sometimes when you sort data, like cities or state, uppercase and lowercase sort differently. And I want a consistent sort for data. I want to make sure that Spokane, no matter how you spell it, is always going to sort together as Spokane. So using a method like this, I could jump back in and force the proper case after the fact. It may be written in my database in uppercase, but maybe my client comes back and says, I want you to give me output that generates an envelope. Well, you don't want the envelope to say, Tom, Affolter, all in uppercase. You would like to have it come back in a professional format, and that's what this one would do. So let's take a look at exactly what this extension method will do. So the very first thing that I do is I take all the words that exist in that Gettysburg, that statement at the beginning, as we did before, and I move that into a words variable. Okay, so now I've got every single different word out there. Okay. Then the next thing that I do is I set a proper string variable here, and that's going to hold the string at the very end when everything is done. I'm going to add into it. You'll notice that I'm building proper string up. So I'm going to grab the first word, convert it to proper, add it to proper string. Grab the next word, convert it to proper, add it to proper string, and so on to it. So let's see exactly what it is. I'm starting it off with an empty string right here, priming it with nothing in it. Now I'm using that for each method that we did before. For every word that exists inside words, I want it to do this. And notice how I'm daisy chaining all of these together. The first thing that I want to do is I want to take the very first character of that string, starting at the 0th location for a length of 1, first character, and I want to make it uppercase. Then after that, I want to add to it everything from the character after the first one to the end, and I want to add that to lowercase, and I want to add a space at the end of each one of those. So again, what it does is it grabs a word, it converts the first character to uppercase, it converts all the rest of the characters after that to lowercase, and then it puts a space at the end of that, and then it stores it back into proper string. So it keeps adding it and adding it and adding it. And let's see what we end up with when we run this guy. So I think I got it uncommented, I got it uncommented, and we're good to go. Let's run it. And sure enough, here we go. First word is 4, score. Every first letter is uppercase, and every letter after that is lowercase. And notice I have a space in between. Where's that space coming from? Right here. If I took that space out, what I would end up with is a giant camelback type statement here. Boom. Everything plugged in together, but just the very first word is uppercase. And I could see where this might be something that you might want to grab, folks, and store this, because there's a lot of value behind this. There is a weakness here, though. It doesn't know when you have like names like McTavish. How do you know that the first, if they're plugged in together, how do you know the second letter is lowercase and the third letter in it is an uppercase if there's no space in between? So there are some weaknesses in this proper, but it is one that actually I have in my tools as well. Now let's take a look at the very last example that I've given you out here. Let's comment this guy out. And now what I want to do is I want to read from a comma delimited file. So what I'm doing, folks, is, and this is very interesting here, is I've got a file out on my drive C here. And what I'm going to end up doing is I want to read all the data inside that file, and I'm going to move that into lines of information. So I've got this file called sample data Spokane weather. It's a CSV file, comma delimited file, and what I want to do is I want to take that and I want to move that into a list. So every line that exists, it's going to read every line, and line by line it's going to throw that into lines, and then I'm going to create a string format very similar to what we did here, but rather than put this directly in the format command, I'm actually going to store that as a string, and I'll plug it in as the format. So I could have taken this entire string right here and put it right here, but I wanted to simplify what this guy looks like right here. But before we continue, I need to talk to you a little bit about what this is doing up here, the format, because we've got this comma in here we haven't talked about before. And what the comma does is it tells it what the length of the number of characters in that respective field will be. So it's telling me right now that the 0th location, this would have been 0 bracket before, is allowed 2 characters. That the first location is allowed 2. Now what that's going to give me is going to give me some alignment help. Then it's telling me that this piece of data can have 2, this piece of data can have 2, this piece of data can have 3 characters. If I wanted to put formatting after this, I could do it right at the very end. So if I wanted to format that as currency, then I could do a C0 if I wanted to, and format at that point. Again, this is optional. I didn't have to do it, but you'll see in a minute what the advantage is. So let's back up and talk about what exactly it's doing here. So the first thing I've got is I've got this file out here, and I'm going to use a new command that we've never dealt with before called a file command. And to use the file command, and I'll show you a quick trick here. Let me get rid of this guy here. So if I come back down and I had typed in file, it would have given me an error because it says, wait a minute, file does not exist. I don't know what file is. Nowhere in any of the packages up above here does it have the file command. There's no system.file command. There's no system.generic, collections.generic.file, no link, blah, blah, blah. So what let's come back down to it again. What I have to do is I have to add that in. Well, how the heck do I know where file is located at? Well, fortunately for us, Visual Studio will give us some help. And if I point to it, you'll see that this little light bulb pops up, and if I click the light bulb, it's going to give me some options. It's going to tell me that that file command is in the package called system.io. So it says, look, you've got a choice. You can either come right in here and add a using system.io. It'll do it for you at the top of the program. It shows me over on the right hand side how it's going to do it. Or I can actually, if I want to, just plug that system.io right in front of file here and tell exactly where it's located at. Let's go ahead and put the using statement up above. And by doing that, it added this using statement here, and that error now should be gone. So let's talk about what this guy does. This command right here reads all of the lines of a particular file, one line by one, and it stores that into a list. So basically what I'll end up with over here in this list array are all the individual lines of this file, sample data. And let's go take a look and see what that looks like here. So I've got this sample data file. It's just a comma delimited file. Comma delimited automatically, it thinks it's owned by Excel, which in fact it doesn't necessarily belong to Excel, but we can take advantage of Excel by opening it up. We can either just go ahead and double click on it to get Excel to open it up, and here's what Excel has given me. And this is all the data that we've got. Now it's showing it to me in a Excel format, but if I really wanted to look at that data in its raw format, I could do a right click and I'm going to open with, I'm going to find Notepad out here. Come on, find Notepad. Oh, it's going to make that difficult for me. So let's do this. It's that CSV, and Excel thinks it owns it. So I'm just going to make it temporarily into a TXT file. And it really doesn't matter. It could stay TXT, but the moment I make it a TXT file now, I should be able to look at it in the preview screen over here. So I'm not going to let me widen that out here. There we go. And here's the data that we're looking at. Just raw data, comma delimited, which means the first piece of data, second, third, and each one of these is a row. Now what's going to happen is when this program runs right here, it's actually going to create a stack of lines, just like this, and each line I can read one line off at a time. And this is the Spokane weather for those people that took the SQL class. This is the equivalent of Spokane weather table, and I've just diverted it back into a comma delimited file. So what we end up with here is the day, the month, the day, record high, record low, all that same information we had before. Doesn't really matter what's here. What matters is, can I read it out? So again, there is the command to read it. I'm reading it line by line. I'm going to store it into a list. So by the time I get over here, and let's put a stop and run it, watch what it does. By the time I get here and I pass that line by, I have an error. File not found. Let me take a look and see. Well, it's not finding it because I didn't change the name back of that file back again. So give me just a moment. Let me switch that file name. So voila, by the miracles of editing, I went back in and I changed that. You'll remember a minute ago we put that as a text file to look at it, and I didn't change it back, so I had to convert it back to a CSV file. So let's just see if I can step through it right now, if it will work, or if it's going to make me rerun. Oh, it worked. So now let's take a look at what line says. Line says that there's 366 lines, and let's look at the lines. And here's all the data now that it sees that are stacked up. And notice that each one has an indice behind it. So I could say jump to the 9th line, which is really the 10th location, and here's the data here. Okay, so let's continue on down here. The next thing I'm going to do is I'm going to build that format of the string. So there's my format. And now I want to loop through all of these lines. So I'm going to call it line. Could call it anything I want, but I'm going to say for each line that exists inside of lines, it's going to grab one line out at a time. I want to strip that line out with commas. I want to pull it out, and by pulling it out, it's going to it's going to take every word and throw that into words. And then I simply am going to use that format that I had right here, and I'm going to plug those in. I'm going to plug the 0th word here, and it's going to take 2 spaces. Then it's going to put a slash after it. Then I'm going to put in the second one right there. And it's going to put a space after it. Then it's going to put this item in right here, and so on and so on. And then I should be able to see it on the screen. Let's continue the running and see what it looks like. Ta-da! So what I've got here is I've got the output. And notice the space in between here, right there. Why did it do that? It did that because I told it that that allowed for 2 spaces, and since it was numeric, it right aligned it automatically for me. If I took that out, let's take it out, right here, and rerun it. Let's take the stop out, and let's rerun it. You'll see that everything is pushed up together now. So there is no space in between it. And you typically would do that just to align it, but it's an excellent way, folks, for output. And I could put anything in here I wanted. I could say, day. I want the day to pop up. And I'm not having to concatenate it. The day, what is this first one? I think this is mean temperature, if I want it. And let's rerun it and see what it looks like. So now I've got day popping up, and I've got the mean temperature popping up along with it. So that format command, folks, is much better than trying to figure out how to concatenate everything together. And it's so much power, but besides telling it how wide to make it, the fact that you could put formatting inside of here, it's extremely, extremely powerful. So hopefully by looking this over, you get an idea of what strings can do for you. I understand this is a quick overview of strings, but what I would recommend you do is I'll give you some exercises to play with, but I suggest that you sit down and just start messing around with it, figuring out what you can do. Take your name, try to do your name backwards. How might you do your name backwards? Well, you could go back in and do a for loop backwards in your name and print every letter out backwards. That would be one way to do it. So there's so many cool things we can do with it. But there is a lot of power behind this doing data management. There's a big demand for people that can manipulate text and strings other than just put in formulas. So give me some feedback on it. Let me know what you think of the lecture. I appreciate it very much, folks.